Hello. In our last video, we took a look at what would happen if we had an array of elements and we wanted to shift the values of that array in some direction. In particular, we looked at shifting them to the right. So in my array, which was indexed from 0, I had, well, let's make that look more like an array. I like to think of an array as a bunch of boxes. So here we go, a bunch of boxes. So in my array, which represented a row of people at the movie theater, I had Bo, Cy, Di, and Ed. And Al wanted to sit down where Bo was. Al wanted to sit next to Bo, and that meant everyone needed to slide down. And when everyone slides down, it turns out Ed is going to sort of fall out of the seat right here. So first Ed gets removed for everyone to slide down. So that's going to happen first. Then Bo, Cy, and Di are going to slide down one position to the right so that Bo will be here, Cy, Di, and then now there'll be room for Al to sit down where Bo used to be. And what we realized when we were taking a stab at how to shift Bo, Cy, and Di down to the right, which is really the crux of this problem, is that would mean Di has to move from C2 to 3. So, and there are many ways we could do this, but I think the easiest way is definitely to move Di first, and then Cy into Di's position, and then Bo into Cy's position. So let's see. Ed is gone. Di, who was in seat 2, moves to seat 3. That's the first thing. And Cy, who is in seat 1, moves to seat 2. That was the second move from 1 to 2. And then we move Bo from seat 0 to 1. Bo moves from seat 0 to 1. And then Al can sit down in seat 0. And we can return Ed, because our shift right method was going to return the name of the person who fell out of the chair at the beginning, at the right end of the row. And when we wrote the code, we found it helpful to ask ourselves who moves first, and from where do they move, and where do they move to, and then who moves last, and where do they move from and to. And when we made this little chart of where we're moving from and to, we realized that either one of these ideas, where we're moving from or where we're moving to, could serve as the index variable of our for loop that does the shifting one element at a time. We're repeatedly moving an element, therefore we'd like a loop. For loop seems like a good way to go. So we're going to have a loop index, and that index is either going to go count 2, 1, 0 or 3, 2, 1. Either way is fine, but we need to commit to one of these two ways. It's not enough for us to make a loop for I equals 2 down to 0 or 3 down to 1. We need to remember whether I meant the place I was shifting from, or I is the seat I'm moving into. And therefore, my strong advice, and I owe this advice to a colleague of mine, and I think it's great advice, is to make my loop index be the word from or to, and then I'm not going to forget whether this is the place I'm shifting from or to. And this idea, a problem where I shift elements in an array, comes up all the time. If I want to make a scrolling video game, if I want to insert an element in the middle of some list structure represented as an array. So you may not see this particular problem, but you'll probably see problems like this many times. So this idea of thinking about my loop index meaning from or to, and then keeping track of who moves first, and where do they move, and who moves last, I think will pay off. So we wrote our method to use the variable from. So this was the last person being saved. So that's Ed falling out of his chair at the end, at the right-hand side. And then the first person who moves is in the second to last seat. Right, the last seat is people.length minus 1, so the second to last seat is people.length minus 2. And the next move is going to be from is counting down. It's counting down, and the last person who moves from seat 0, hence greater than or equal to 0. And then the person at seat from moves into seat from plus 1, right? We move from that number to that plus 1. And then the new person sat down on the left-hand side, and we returned the person who we removed. And one of the things to note about this code is, look at how many places we can mess this up. What if we wrote people.length minus 1 instead, or from strictly greater than 0, or we accidentally incremented from, or we mixed up, made that from minus 1, or swapped from plus 1 and from. There are 5 places in this program where if I'm not completely on my game, and I have the slightest mistake in my thinking and I'm off by 1, it may take me hours to find this error later and correct it. So I want to be extremely careful whenever I write something like this. I want to stop and reason it and try it with numbers and be absolutely confident in all 5 of these parts of the code so that I'm certain I'm not going to have to chase down some nasty bug later. I want to take another stab at writing this method, but this time I want to shift left. Or sorry, we'll do that next. I want to shift right one more time, but this time I want to shift right, public static. It's going to return a person, the person who falls out. It's still called shift right. It's still taking in all of these people, including the new person who's going to sit down on the left-hand side. And I'm still going to do everything I started by doing, right? I still make a note of who gets removed. The person who gets removed is the person in the rightmost seat, the last index being people.length -1. But now, I want to try writing my loop using to instead of from. So using this column, which I'll call 2, the seat I'm moving into, the index I shift an element into, instead of keeping track of the index I shift from. So what's the first place that someone moves into? Well, they move into the last seat, the rightmost seat, and the last seat is people.length -1. What's the last place someone moves into? Well, the last place someone moves is, the last move is from 0 to 1, so 1 is the last seat someone moves into. So that's, this variable 2 should be greater than or equal to 1. So I want to include shifting into index 1, and that'll be from 0 to 1. And I could also, of course, write that as strictly greater than 0 if I prefer, or greater than or equal to 1. Either way is fine, since 1 is indeed strictly greater than 0, and we're only dealing with integers here. And then, just like before, my index is still counting down, so my variable 2 is going to get decremented. Alright, now inside this loop, I'm moving a person from one position to another. So they're moving, I know where they're moving to. They're moving to index 2. Where are they moving from? Well, they're moving from 2 minus 1. See how from is always 1 less than to, my variable 2? So they're moving from 2 minus 1 to 2. And then, of course, we can now put Al, or whoever person P is, into position 0 and return the person who got removed, since that was my intention. Did I call them remove or removed? Ooh, oops. There, we're missing a D here. No problem. Anyway, look at how different this looks. And look at how easy it would be to mix up these two programs, to sort of start writing one and then end up writing the other. So here we have a different starting point, a different condition. We're still decrementing, but now we're copying into a different place from a different place, and yet the end result is these two programs do exactly the same thing. The only difference is the first one kept track of where we're shifting an element from, and the second one keeps track of where we're shifting that element to. In the next video, we'll try shifting in the other direction, and I think that will give us a good sense of how to solve these problems in general, how to deal with problems where we shift elements, a sequence of elements, several elements, all together in an array. I will see you in that video.